States intelligence officer, is warning that space debris is becoming a serious national security risk, and the situation is getting worse. But we don't have to just take that at face value. We can actually verify that using real satellite tracking data, and what it shows is concerning. Hi, I'm Dr. Amanda Fetch, and my research is in AI in space, specifically space situational awareness and orbital debris. So according to an article by NRO.gov, this warning comes from the National Reconnaissance Office in the United States, where Deputy Director Chris Povak emphasized more satellites, more debris, and more competition in orbit. The article also noted that we're now tracking tens of thousands of objects, and many smaller debris pieces can't even be reliably tracked, but can still cause catastrophic damage, which I actually looked at a similar concern within my PhD research. So to show you in this video what this looks like, I pulled real data from spacetrack.org. And so this system is maintained by the United States Space Force, 18th Space Defense Squadron, and SAIC, and provides orbital data on tracked objects. If you want to try this yourself, go ahead and navigate over to spacetrack.org, go to Query Builder, select GP for general perturbations, add a simple filter. What I used was NORAD_CAT_ID is greater than 0. Click Build Query and then run the query. And you can download the results as a CSV file within that process. So the analysis I did in Python. And so what I found from that data set is about 25,000 objects between 200 and 500 kilometers, about 17,000 are between 500 to 1,000 kilometers, and about 5,500 are between 1,000 to 2,000 kilometers. So that's about a little over 40,000 objects concentrated in low Earth orbit specifically. And so this is what makes the problem more complex, is that this data isn't necessarily completely evenly distributed. So you have thousands of objects moving at extreme velocity through the same narrow orbital bands. And so when we think about this, now we're not just looking at more objects, we're looking at more objects that are operating in the same space. And so what I should say is to take this a step further, if we looked at my PhD research, I applied clustering techniques to this type of orbital data to understand not just where the objects are, but how they're behaving. And so this is a visualization taken directly from my dissertation and my doctoral research, where each point represents an object in orbit, and these are grouped by similar behavior and characteristics. And so what you're seeing is we have dense regions to objects behaving similarly. We have structured clusters to show us predictable patterns. And most importantly, we can also see outliers. And so these outliers, similar to what is done in anomaly detection, represent objects that don't behave like the rest. And from an operational standpoint, those are often the ones that require the most attention. And so this ties directly back to this article by NRO.gov. And so at orbital speeds, even a small piece of debris can cause catastrophic damage. And as mentioned in the article, many smaller objects aren't even being tracked. And so as I mentioned prior in the start of this video, that's another point I drove home in my research. And so now you have congestion, you have high velocity, and you have incomplete visibility. And so when the NRO talks about increasing risk, we're not just looking at the amount of objects. We're also looking at where the objects are located in orbit, how concentrated they are together, and again, how they behave. And so I have a question for you to think about. Should we continue treating all objects in orbit equally? Or should we be prioritizing high-risk objects using AI and clustering methods, for example, like what I did in my research? Would love to hear your thoughts in the comments. Thanks for tuning in. Take care.